let us look at what is in this lesson. This lesson is a little bit easier than first lesson, I would say. So we studied about motion in one dimension, object along a straight line in terms of its position, velocity, acceleration. Object is not moving, left and right. It's moving one direction only. So if a ball is rolling on the ground like this is motion in one dimension. If insect goes like this, then it is moving in x direction as well as y direction. This is called two-dimensional motion. What is three-dimensional motion now? A bird flying can move x, y, also up and down. So it is three-dimensional motion. A bird flying is three-dimensional motion. If you throw a ball, it can go for the wind, it can move left, right, also up and down. They're all three-dimensional motion. You're going to study this till class 12. We saw that such motion can be uniform or non-uniform. We studied. So if an object travels equal distance in equal intervals of time, we call it as uniform motion. If it is going fast, then slow, then stops, then again fast, then it is non-uniform motion. No problem with motion, uniform motion, non-uniform motion. Is there any difficulty with the definitions? Rishit, Lakshanya, are you okay with
No,
this?
ma'am.
Uniform, non-uniform motion, you all know. Equal distance in equal intervals of time is uniform. If it is not, it is non-uniform. We have not yet discovered what causes the motion. Why does the speed of an object change with time? Do all motions require a cause? If you push or pull, there is a motion happening. Is there a motion possible without a push or pull? So, what is the nature of this cause? In this chapter, we are going to study about all these questions. Okay. So, for many centuries, the problem of motion and its causes puzzled scientists and philosophers. They didn't know the why it should move, why it should stop. A ball on the ground, when given a small hit, does not move forever. If you in the carom board also, if you toss a coin, it goes to some distance and then stops. It is not moving forever. Such observation suggests that at that time, 200, 300 years ago, they thought that rest is the natural state of an object. So why is the ball stopping after some time? You start the swing, it is swinging for some time and then finally it comes to stop. They thought that rest is the natural state of an object. So that's why it is coming to the natural state after some time. So this remained the belief until tomorrow, until Galileo Galilei and Isaac Newton. Wherever you lost mark, you redo the questions. So you have to remove the speed. So they were thinking about like this until Galileo Galilei and Isaac Newton, around 300 years more. When is Isaac Newton's time? Till then, they thought objects' usual state, natural state is rest. So 1643. Okay, almost 350 years, 380 years. Till then, people thought that rest is the natural state of an object. Then what happened? So Galileo Galilei and Isaac Newton developed an entirely different approach. So here You are pushing the trolley, it is moving. Here you are pulling a dryer, it moves. So a push or pull, a force causes the motion. Change the state of the motion. A push or pull starts a body at rest or stops a body in motion. Is it possible to start or stop an object without a force? So, what is force? Force is a push or pull, and force causes motion. So, force can start an object at rest into motion, or already moving object can be brought to rest. Is it possible to cause motion without force? Is there any example that you know of that is not associated with the force? I'm just dropping this pen, it falls. Earth's gravitational forces acting on it, pulled by the Earth's gravity. So without force, there is no motion. But after force also, motion can be there or motion need not be there. Okay. If I push the wall, there is no motion. If I am applying, I am trying to push the wall for 1 hour, still the wall will not move. So force, if force is no, motion is also no. Okay. If force is yes, motion can be no or motion can be yes. Example of motion noma, pushing a wall, or a small child or small baby try to lift a book, heavy book. Small kid trying to lift a heavy book.
Ma'am, can I leave?
Ah, okay, Kundana. What happened? You for so long you didn't respond.
No, ma'am. Like my tab got switched off.
Okay. From
So
5:40. Okay, ma.
ma'am,
You can leave. From 5:40, I was trying to reach you.
5:40 onwards. No, my tab got switched off at 5:52 something like that.
Okay, ma. You can leave.
Okay, ma'am.
Bye, ma. So motion is there, force is there, motion is also there. Example, ma. Kicking a ball, pedaling a bicycle, or stopping a ball. It is coming to rest. Change in motion. We can even say change in motion. Force no, change in motion. Okay, so force is applied, motion is also happening. Force is applied, but still no motion is happening. Are you able to follow this, Rishit? You're applying force, but no motion.
Yes, ma'am.
Another example is you applied force. Example number one, example number two, example number three. Example number three, if there is a box or a box or a box or a book, whatever it is, if one person pushes it this side, another person pushes it the opposite side. Multiple forces are acting, but still the book is not moving. Equal and opposite. So force is there, but there is no motion. So F1 is equal to F2 equal and opposite, then also there is no motion. So there can be motion, there can be force, but no motion. We studied three examples. One, that's a heavy object. I am unable to push, no matter how much I try. And for the small kid, the heavy book is she's unable to lift. And if equal and opposite forces are applied, then it is not the net force is zero. Here, net force is zero. It is not necessary that only one force is acting on a body. Multiple forces are acting. Net force is zero, so no movement. If force is applied, then motion is also there. That means you can start a stationary object or you can stop a moving object. Both can be example of this. Now let us look at the next one. So in our daily life, we observe that there is definitely some effort is required to put a stationary object into motion. Do you agree? Or to stop a moving object. That also you need to do some effort. We ordinarily experience this as a muscular effort and say that we must push, hit, pull to change the state of motion. So the concept of force is based on the push or pull. So what is force? Nobody can see, taste, or feel force. We can feel the force, right? We can feel the effect of force. If heavy wind is there, we feel like getting pushed. So we can feel the force, but we cannot feel the effect of force. It can only be explained by describing what happens when a force is applied to an object. One more water also can. Pushing, hitting, pulling are all ways of bringing objects in motion. Why do they move? They move because we make a force act on it. So without force, no motion is possible. Keep it there only. You can keep it. Not nice. I change every day. So you also are familiar with the fact that force can be used to change the magnitude of velocity of an object. Can you give me an example, Bob? Rishit, how can you move an object? Moving object is there. How can you make it go faster?
by applying force.
By applying a force. So a ball is already rolling. You're applying a bit more force.
Yeah,
A ball is already moving. If you apply the force opposite, it will slow down.
it will slow
Automatically
down.
stop. So number one, force can be force can be um, start make an object move from stationary. Make and make a stationary object move. Number two, make a moving object stop. Number three, make a moving object move faster. Number four, make a moving object to move slower. How do you do? By applying opposite force. Opposite force in opposite direction, you are slowing it down. Do you agree, ma? All 4 points? Any objection? Rishit, Lakshanya, shall we continue? Force can also change the shape and size of the body. What are the things that are possible by force? So, force can change shape. A balloon, sponge can change the shape. Rubber band, or it can change size. Force can do all these things. Do you agree, ma? All these are possible by a force. Here, shape is changed. Here, size is changed. Shape or size. Okay. Here, shape is changed. Here, size is changed. Okay, finally, we are coming to a definition of force. After all this explanation, force is a push or pull. Now, let's move on to balanced and unbalanced force. So, we have a picture. A wooden block is there. If two forces are applied on it, F1 and F2, equal and opposite, what is the net force? Net force is zero. That is called balanced force. You are applying force, but still it is not moving. That means net force is zero. So two strings X and Y are tied to the opposite faces of the block. You are applying a force by pulling the string X. Another string Y also you are pulling. So both are equal and opposite. If the block is pulled from both sides with equal forces, the block will not move. Any objection to this? Equal and opposite forces are called balanced forces. So object is already at rest, it does not move. Object is already moving, it does not stop. But if the forces are not equal, then what happens? There is a net force that is called unbalanced force. Look at this question. Look at this picture. So look at this picture. Two people are pushing the box. This is muscular force. This is frictional force. Muscular force F1, frictional force F2. Who is offering frictional force? The ground is offering frictional force. Here, both are equal. You see, the arrow mark is same size. F1 is equal to F2. Do you think the box will move? Net force is zero, no movement. This is at stationary, box is at rest, it will continue at rest. No movement. This is balanced force. Picture number 2. They are applying more muscular force. Frictional force is also more. Here also F1 is equal to F2. Balanced force. No movement. So first they try to move, then they are trying hard to move it. Frictional force is also equally more. And finally, now they are able to move much more harder. And frictional force is less than F1 is greater than F2. Can you see the picture, ma? F1 is greater than F2. What happens now? The box moves. Unbalanced force. F1 minus F2 is not equal to 0. So, which side it is moving? The direction of F1. So, movement is there in direction of F1. Movement is in the direction of F1. If F2 is more, movement will be in the direction of F2. Any objection? Do you all agree? Abhiram, do you agree? Applying less force, applying more force, but still unbalanced, so no movement. Lakshanya, you're having internet issue, ma?
Ma'am, I had a power cut.
Did you miss any of this ABC?
Yes, ma'am.
Did you listen or did you miss? Okay, so if F1 is equal to F2, balanced force, no movement. More F1, here more F2, so balanced force, no movement. Here more F1, less F2, then it is unbalanced force. There is movement and also it is in the direction of F1, whoever is dominating that force. Lakshanya, are you okay with that?
Yes, ma'am.
So, what happens when we ride a bicycle? We are overcoming the frictional force of the road. Only then the cycle starts moving. So, we are applying more force than the frictional force. And the object maintains its motion under the continuous application of unbalanced force. It appears. As long as you pedal, it keeps moving. You stop pedaling, for some time it moves and then it comes to a stop. So you feel that continue to apply unbalanced force, the object will move. But this is not correct. Let me repeat, ma. You feel that you roll a ball, you give a push to the swing, it keeps swinging. If you stop moving, after some time it stops. So you think that if I continuously apply force, it will continue to be in motion. Is that true? We feel that it is true. But in physics, actually, it is not true. What they're, what they're saying is, if an object is at rest, you apply a force, it will start moving. No? They're saying it will move forever if there is no frictional force. If there is no, if you have a, if you achieve a highly polished surface, and if you roll a ball, that's it. It will keep moving forever. If you can achieve zero friction, if you can achieve zero friction, in theory, it is possible that the ball will roll on forever. If at all you can make such a surface, highly lubricated, highly slippery surface, the ball will roll forever. Same with object in motion will continue to be in motion, object at rest will continue to be at rest. That is the theoretical concept. There is no friction, no opposing force. So an object moves with uniform velocity when the forces act on the body are balanced. As long as it is balanced, it will continue to be in motion. There is no net external force on it. So, as long as it is balanced, it stays in the same state, whether it is rest or motion. If there is any unbalanced force is applied, only then there is a change in state. There will be either change in speed or the direction of motion. So, to accelerate the motion, unbalanced force is required. This can be a assertion proof question. Do we need to keep applying force? Only unbalanced force is needed. Unbalanced force is needed to change the state. If it is balanced, the moving object will continue to be in motion, the rest object will continue to be at rest. Only unbalanced force will bring a change in the state, or change in speed, or change in direction. So, this is a very important point, concept point. In our daily life, we think that we should apply force periodically. The object should keep moving. You have to continuously pedal. You have to continuously press the accelerator for an object to move. But that is not the case. An object maintains motion under continuous application of unbalanced force. If friction force is not, if you are unable to make frictional force zero, you have to apply the force more than the frictional force. Then also the object will be in motion forever. No problem. If you don't understand, ask me. I'll repeat this once again because it is basic. Object maintains its motion under the continuous application of unbalanced force. It is quite, that's what we feel. But what is actual? An object moves with uniform velocity when the forces acting on the object are balanced and there is no net external force on it. You don't have to give unbalanced force. You have to, only starting you have to give unbalanced force. Then after that, balance is also good enough. So, if an unbalanced force is applied, there will be change in speed or direction. To accelerate, unbalanced force is required. Only if you want to accelerate or decelerate, unbalanced force is required. And the speeding and slowing will happen as long as there is unbalanced force. What they are saying is you pedal and then you stop pedaling, it will go forever. You start the car, come to some speed, and then you don't need to drive it anymore, it will keep going forever. If the balanced force is zero. So unbalanced force is needed only to start. Balanced force is enough to continue. Let me write. So unbalanced force causes motion, whether it is starting or stopping. Once it starts, no, then balanced force is enough to continue. That's what they are saying. If you want to accelerate the motion, unbalanced force is required. Then if you stop this force, it will continue with that same velocity. Showing. Once you apply unbalanced force and it starts moving, you apply balanced force, that is enough to continue forever. Only starting trouble, stopping trouble. Remaining can be managed. Rishit, are you okay? Shall we move on to the first law?
Yes, ma'am.
First law is so simple. An object at rest continues to be at rest. Object in motion continues to be in motion until uh, inertia, law of inertia. First law. So we are going to study three laws of motion now. Every action has an equal and opposite reaction. Newton's laws of motion. Last lesson we studied three equations of motion. Now we are studying three laws of motion. This is also called as law of inertia. Inertia means some laziness kind of thing. There is no, there is a lack of movement. So law of inertia is opposing the change. You don't want to change. Whatever you are doing, you want to continue doing the same thing, like that. So look at this. By observing the motion of objects on an inclined plane, we don't. Where do we see inclined plane, ma? Wherever you see ramp, the shopping mall, wheelchair can go. It is all inclined plane. Galileo did an extensive experiment on inclined planes. He deduced that objects move with a constant speed when no force acts on them. So, see, in reality, we cannot achieve zero friction. No matter how much you try, you cannot achieve zero friction. If you take an inclined plane, a flat ramp, the friction and the slope will balance. Okay? It will keep moving forever. That's what Galileo Galilei is saying. Objects move with a constant speed when no force acts on them. If it is inclined plane, he observed that when a marble rolls down the inclined plane, in a small marble, have you guys played with marbles? It will it will keep moving. Its velocity increases if it rolls down the inclined plane. You will learn that a marble falls under the unbalanced force of gravity as it rolls down and attain a definite velocity by the time it reaches the bottom. So when it is rolling down, velocity increases. You can roll a marble upside also. Then velocity decreases. After reaching some distance, then it will start rolling down. So 5B and 5C shows marble resting on an ideal frictionless plane inclined on both sides. 8.5B, 8.5C. What did you say, Ma? We'll do that. What do they mean? Just give me a minute. Keep reading. he has taken two equally inclined planes. If this is like, you can imagine like a slide. Okay, this is 30 degree, this is also 30 degree. Both are similar. This is same, this is same, this is same. Two identical inclined planes he has taken. And then he observed that if he release the marble here, from here, position 1, position P1 or position P, it climbed till P. That's what they are showing. If he took two equal identical inclined planes, if he started the marble at P, it came all the way down and climbed all the way up the same distance. Suppose if he started the marble at Q, it came all the way down and climbed all the way up to Q here. If he started the marble at R, it came all the way down and climbed till here. That means it reached the same height. That is his experiment, famous experiment using inclined plane. So velocity decreases when it climbs up, velocity increases when it is coming down. So 8.5C, look at this picture. Instead of taking two identical inclined planes, he now started experimenting with unidentical inclined planes. Lakshanya, what did you miss, ma? Did you miss any? Lakshanya, did you listen to PQR positions?
Ma'am, your voice is breaching.
Is it Rishit? No. So now he has taken non-identical inclined planes. Look at the inclined plane number 1, inclined plane number 2, inclined plane number 3, inclined plane number 4. Are they identical? Here they are all 30 degree, 30 degree. Here this is different, this angle is different, this angle is different, this angle is different. Okay, so he keeps decreasing the right side inclined plane. So if this is released from this position P, look at this position Q, R, R, S. I mean, all are P only. It is reaching that much height. But is this distance equal? Let me call it as O. Let me call it as Q.
Ma'am, your voice is breaking.
What is it, Mar? Lakshanya? So he now used different inclined planes. The black wala, blue wala, red wala are all different inclined planes, not identical with the left side. So, hello Sharanya, give me a minute, ma. PO,
Hi, ma'am.
give me a few minutes, ma. PO is equal to QO if identical inclined planes. PO is less than RO, SO if the right side inclined plane is flatter. Right hand side of inclined plane is flatter. Ritvik, Rishit, don't worry, ma. I'll send you the
Ma'am, I
recordings.
can't hear you.
Are you able to listen? Sharanya, give me a few minutes, ma. So if I keep flat, keep making the right side inclined plane flatter and flatter.
Ma'am, we are unable to hear you.
You're unable to hear. What did you say, ma? Lakshanya, Sharanya? You can't hear. Let me rejoin then.
Ma'am, we can't hear you. Still.
Wait a minute, I'll change the net. Is it any better, ma? Now it should be better. I changed to much better net. Can you hear me now?
Yes,
Lakshanya,
ma'am.
Yes, ma'am, ma'am, we can hear you.
now you are able to hear? Okay, ma. Give me a few minutes, Sharanya. I will wind it up.
Ma'am, can I leave? Okay.
Just 2 minutes, ma. PO is equal to QO. QO is less than RO is less than SO less than TO. This is T somewhere. So he kept the right side inclined plane flatter and flatter, and he observed that it is moving for longer distance until it reaches the same height. So if you make the right side inclined plane flat, that means it should move forever. Why? Because it is never reaching that height. The height is the problem. It wants to reach that height. It is unable to reach the height, so it will roll forever. This is the basis for law number one. We'll continue this tomorrow. You can log off, ma. Lakshanya. We'll continue with Newton's law one tomorrow.